Welcome to another episode of Tech Mysteries Unraveled, where we dive into the world of programming languages, uncovering the unique concepts that pique our curiosity. Today, we're exploring a fascinating but somewhat unconventional language called Rivulet. Hey everyone, I'm thrilled you're joining us today. If you've ever been intrigued by how different programming languages can change the way we think about coding, then you're in for a treat. So, let's plunge into Rivulet. Now, Rivulet is not your run-of-the-mill language. Instead of using traditional syntax, it employs something it calls strands. Imagine strands of a flowing river, smoothly combining to create a remarkable pattern, so much so that it draws inspiration from art, such as Ani Albers's Meanders series. Isn't that just poetic? To give you a sense of what we're dealing with, in Rivulet, programming constructs are organized into what they call glyphs. Each glyph consists of strands that run together, like a team of synchronized swimmers. The neat part? These strands execute simultaneously. It's almost like a dance, don't you think? Now, within this framework, you don't have typical branching or looping. Instead, Rivulet uses what's called a conditional rollback. This means if a strand leads to a situation you didn't want, you can roll back to the previous state. Let's say you're on a road trip and you take a wrong turn. You can backtrack. Isn't it comforting to know this exists in coding? But here's something to ponder. How do you test the conditions for rollback? Rivulet introduces special strands called question strands. They act as the guardians of your strands, assessing whether they meet your criteria. If they don't, it triggers a rollback. It's a fascinating way to manage flow without cluttering it with traditional control structures. It makes you wonder how much we rely on if statements in other languages, right? Rivulet also organizes data differently. Instead of having arrays or objects as we know them, it utilizes lists of adjacent cells filled with zeros by default. Commands can act on individual cells or an entire list, almost like how a painter chooses whether to use a brush on a single dot or splash paint across the canvas. And speaking of commands, let's touch on the action strands. They dictate how values are treated within those strands. So if you wanted to raise numbers to a power, you'd apply an action strand directly beneath the data strand. It's like giving directions to a very obedient dog. Pretty neat, right? Before we wrap up, let's talk glyphs and their syntax. Rivulet's grammar might initially seem daunting, but once you grasp it, it can become intuitive. Glyphs start and end at specified markers, and the way you arrange them can alter their meaning. Picture a jigsaw puzzle that only fits together in a particular way. So to sum it all up, we've unraveled the flowing strands of Rivulet, a programming language that breaks the norms of traditional coding with its artistic, fluid syntax, and structural elegance. It's a beautiful blend of art and function that challenges the way we usually interact with code. Now I want you to think, how might Rivulet influence our understanding of programming languages in the future? Could elegant design change the way we write code altogether? Thanks for joining this exploration of Rivulet. Keep questioning, keep coding, and remember, sometimes the most unconventional paths lead to the most exciting discoveries. Until next time, this is Tech Mysteries Unraveled, signing off. Happy coding.